So we're on now to question 7. This is the first of the context and applications questions, the problem solving question, and each one is worth 50 marks. So our first question begins here with Marcus. Marcus is in charge of restoring an old theatre. He's replacing the stage and has been given a plan for the typical dimensions of a theatre stage. The plan of the stage is in the shape of a rectangle joined with a semicircle. The length of the rectangular part is 2x meters and the width is y meters. So we have our 2x, our y. The diameter of the semicircle part is 2x meters. So this is our diameter, which is 2x. And of course, that means our radius will be 1x. Okay, so the diameter equals 2x, the radius is equal to 1x. The perimeter of the stage is 80 meters. Using p equals 80, show that y would be equal to 80 minus 2x minus pi x over 2. Okay, so what do? We start off, we say, right, we know what we have here. We have in our stage, we have our 2x, we have our y, we have our y. So that'll be 2x plus 2y, plus we have the circumference of the semicircle. And of course, it's only the outer part, not the dotted line. So in our case, so we start off and we say, when we're working out the circumference of a circle, well, the circumference of a circle is 2 pi r. So if a semicircle is 2 pi r divided by 2, which is pi r, but we know that the radius is equal to x, so our circumference is going to be pi x. So note in our answer, we can see a pi x there, so that's helpful. Okay, so our perimeter is the 2x, the y plus the pi x, and it's equal to 80. So at all times, we're keeping an eye on our answer, and we know we need to isolate y. So that's what we're going to head towards. So we're going to say 2y is equal to 80 minus 2x minus pi x. And all of a sudden, we're almost there because we say y is equal to 80 minus 2x minus pi x over 2. And that's it. So we got there for 5 marks. Now, the good thing is, even if you didn't get that right, even if you made an error, you can still continue. We have our perimeter now, y equals 80 minus 2x minus pi x over 2. It says, hence show that the area of the stage is given by area A equals 80x minus 2 plus pi over 2 x squared. And of course, hence tells us we have to use the information we've just gotten from part 1. So we know the area of a circle is pi r squared. So if a semicircle is pi r squared over 2, we know the radius is equal to x. So it's going to be pi x squared over 2. That's our area. We know our area of the rectangle is going to be 2x times y. Okay. And we know, of course, we have isolated y previously. So we have the area is 2x times y plus pi x squared over 2. From the previous part, we know that y is equal to 80 minus 2x minus pi x over 2. So now we're keeping an eye on our answer, what we need to get to. Okay, we're going to multiply through here. We can see the 2's will cancel. 2 will divide into 2. So then we're going to get 80x minus 2x squared minus pi x squared plus pi x squared over 2. So it's basically saying, like, you could imagine if we had kind of minus p and then plus p over 2, you'd end up with minus p over 2 because it's minus 1 plus a half. So in this case here, we're going to end up with 80x minus 2x squared minus pi x squared over 2, because minus pi x squared plus pi x squared over 2 will give you minus pi x squared over 2. We have a look at our answer. Our answer is just a little bit different from what we have here. Now, I'll give you a clue and a hint. If you get to a line like this one, and you got to get down as far as here, but you're not quite sure how to do it, if you just write down your answer, and put in therefore. Sometimes it's very hard for us people correcting the exam to know if you've understood what you've done or not. We just probably have to give you the benefit of the doubt. In this case, what's happened is we basically factored out a minus x squared from here. Okay, so it's like we factor out a minus x squared, like a minus 1x squared. So if you picture being a minus 1x squared, and we put the minus 1 here in the front and the x squared over here, and that's why the sign of the 2 and the pi over 2 have changed to be a positive. Okay, so if you multiply everything back out, you'll see that you will go back from here to there, so it's done correctly. Now, that was another 5 marks. So we're up to 10 marks, okay? And not the easiest 10 marks to get. But it then says, use calculus to find the value of x for which A is a stationary point. So a stationary point, another word for a turning point. Now we have this here. Now, a lot of students will struggle to differentiate this. However, if we just follow our differentiation rules, you have 80x to the power of 1. That will differentiate down to be 80, multiplied down by the power, reduced to power by 1. So that'll just become 80. Now, it's the same thing here. It looks complicated because of what's inside the bracket, but all this stuff here is just your coefficient on x. So if I better put in the if here, like if y was equal to 3x squared, so if y was equal to 3x squared, then dy dx would be equal to 6x. We know that, right? So it's the same thing here. You're just multiplying down by the power, and you're reducing the power by 1. So you get minus 2 times 2 plus pi over 2x, okay? And we know that when we multiply this through here, so we're going to get minus 2 times 2, when we're keeping our minus outside the bracket, so we're actually just multiplying through the 2. So 2 times 2 gives you the 4. 2 times pi over 2 gives you pi. So we still have maintained our minus outside the bracket here. I'm just writing it as a minus 1. We know that the turning points occur when the first derivative is equal to 0. So dA dx equals 0. So in this case, we get 80 minus 4 plus pi times x is equal to 0. And we get x on its own. We get x is equal to 80 divided by 4 plus pi. Okay. And that was 10 marks. Now, you have always got to remember that we had our answer, we're given our answer for the first part, part I, we're given the answer for the second part, and we use that answer for the second part to get your stationary point, okay? Now, even if you'd only picked up low partial credit in the first 2 parts, you can still get full marks here for 10 marks, okay? Because you had your answer. It then says, prove that the value of x that you've gotten in part 2 gives the maximum. So we know that that was our function for a. We have our first derivative here is 80 minus 4 plus pi times x. And remember, this is x to the power of 1. And again, if you had y equals x to the power of 1, well, dy dx would just be equal to 1. Okay, remember I'm saying if here now, that's just an example. So here we multiply down by the power, the constant disappears, of course. We multiply down by the power, we reduce the power by 1. So we end up with x to the power of 0, which is 1. So our second derivative is minus 4 plus pi. And obviously that's all inside in a bracket. So like my answer is in decimal, it's going to be like minus 7.14. It's a negative. So because my second derivative is negative, I am dealing here with a maximum. Okay. And that was another 10 marks. So now we're up to 30. And for students who are good at differentiation and don't get scared by the pi, which makes it look a bit more tricky, those last 20 marks were not too bad. Calculate to the nearest meter squared the maximum area of the stage. So in the case, we had the maximum occurring at 80 all over 4 plus pi. And we sub in 4x. So we sub in here and we sub in over here. We can put all that into calculator if we wish. And we're going to get an answer to the nearest meter squared, 448 meters squared. And that was 5 marks. Don't forget to keep in your unit. Now we go on to the next part. Whilst completing the work, Marcus finds a leak in the bowl, a leak in the roof. A bowl is put down to catch the water, and Marcus watches it filling as he waits for the leak to be fixed. When the depth of the water is h meters, the volume in meters cubed is given by this function. Volume is equal to 1/12 pi h squared times 3 minus 4h, and h is between 0 and 0.25 meters. It says find in terms of pi dv dh. Now, okay, it looks a bit complicated, but you're just being asked to differentiate this function, which is already in terms of h, okay, and then sub in 0.1. So what I've done here first is I've just multiplied through. So 1/12 pi h squared times 3 is going to be 1/4 pi h squared. 1/12 pi h squared times minus 4h is going to be minus 1/3 pi h cubed. So now I differentiate those. Again, same thing, multiply down by the power, reduce the power by 1. So we get a half pi h minus pi h squared. Don't forget to sub in h equals 0.1. And when I do, dv dh is a half times pi times 0.1 minus pi times 0.1 squared. I get my answer, which is pi over 25, which is 0.04 pi. So either of those answers is okay. However, as I look at it here, I would also like to say that it is changing in, I suppose, meters. dv dh, yeah, so the volume is going to be like meters cubed per meter, isn't it? So for my unit, but I wasn't asked for that, but it's the volume is meters cubed, the height is in meters.